So students, today in the subject of complex variables and partial differential equations, let us see another topic. You know, last time we have seen how to form partial differential equations. This we have seen in two forms. First type we have seen in which the elimination of arbitrary constants, and in the second type we have seen elimination of arbitrary functions. And I told you that this topic was very simple. In continuation with this, now we go for the solution process of partial differential equations. As I told you last time that it depends upon the nature of the partial differential equation. Based on nature of these equations, there are different kinds of techniques that we can use to solve partial differential equations. So here, today we want to see Lagrange's first order partial differential equations. So friends, these equations are very simple to solve. Every year in examination, one question always comes of 3 to 4 marks. So you can secure 3 to 4 marks very simply, very easily. Here you will require to know some of the simple and fundamental procedures, techniques. But before that, just I would like to say that here the book, which book will you use? You can use the book. Here I am using the book CVPDE by Dr. S.S. Patel, that means myself, published by Atul Prakashan. So you can find from this book lots of examples solved, and also the examples solve examples which are asked in previous GQ examinations. So here, now we come to the point. Lagrange's first order partial differential equation, when we want to solve this kind of differential equation. Solution is nothing but the process of removal of derivatives. And as we know that partial differential equation contains partial derivatives like del z by del x and del z by del y. Here also, first order means the equation will contain only first order derivatives. That means del z by del x, del z by del y. And here also, in this we want to see linear equations. Linear equations means the degree of the derivatives involved in the equation is 1 only. It is not greater than 1. So this is linear partial differential equations of order 1. So here Lagrange's equation has the form special type capital P into small p plus capital Q into small q equal to R. This is known as Lagrange's first order partial differential equation, where as last time discussed, where small p is nothing but del z by del x, small q is nothing but del z by del y, and capital P is a function of x, y, z, q is also a function of x, y, z, and R is also a function of x, y, and z. That means the equation contains two first order derivative, del z by del x and del z by del y. So here we know that it is not involving del square z by del square del x square or del square z by del y square. So as it is not involving second order and it only involves first order derivatives, we say that this is first order partial differential equation. Now we want to solve this equation. We want to find out the solution of this equation. So we will see two techniques to solve this equation. First is the method of grouping. Both methods are very simple. Simply you require some logic. If you use the logic, you can do it very easily. Within 2 to 3 minutes you can solve it. Then the second method is method of multipliers. So here we will solve this equation. To solve this equation, we will have to the solution procedure. First let us see. We will have to write down auxiliary equations from this given equation. Auxiliary equations can be written directly from the given equation. This will be given to you. So dx upon capital P, dy upon capital Q equal to dz upon capital R. And this is very simple. You can identify the coefficient of small p, coefficient of small q, and the right hand side. Sometimes this can be written into alternate form. That is q into capital Q into small q plus capital P into capital P. Then you will have to be careful to identify what is capital P, what is capital Q, and what is capital R, because sometimes R may also be written on left hand side. But you will have to consider this as it is on the right hand side. That means minus sign cannot be involved unnecessarily if it is given on left hand side. So first step is to write down auxiliary equations. Understanding? Okay. Now we will solve these auxiliary equations. There are 3 equations. We will call this as 3 equations. So we will solve these 3 equations and obtain 2 different kinds of solutions. First solution is say u x y z equal to c1, where c1 is an arbitrary constant. And the second solution we will obtain as v of x y z equal to c2, where c2 is also an arbitrary constant. Okay? Understanding? Are you getting me? Okay. Then the general solution means or final solution we can write in the form of capital F u comma v equal to 0. That means the solution u or the left hand side part you write down over here, and the v you write down over here. So this is the general solution. So the main thing here you require is to obtain these 2 solutions, u equal to c1 and v equal to c2. Once if you obtain these 2 solutions, then you simply require to put these 2 values over here. Sometimes you can also write this instead of capital F. You can also write this as phi of u comma v equal to 0, or small f u comma v equal to 0. Whatever you want, you can write down. Or else you can also write the same solution in the form of u equal to phi of v, or u equal to f of v. Whatever you want, you can write down this. Okay, but mostly we will use this type of notation to write down the general solution of this equation. So as I told you that main target is to find out the 2 different solutions u and v. So we will focus now to find out u and v. And to find out u and v, we will make the use of these 2 methods, method of grouping and method of multiplier. Once again here, one point you will require to remember is that for some of the equations we can get u and v both by using the single method, either by method of grouping or either by method of multipliers. But sometimes it may happen that first solution can be obtained by method of grouping and the second solution can be obtained by method of multipliers. So we can also use both the methods to find out u and v. That means one solution can be obtained by grouping method, second solution can be obtained by multipliers method. So if it is possible to find out both the solutions by using a single method, then you can use this approach. But if it is not possible, then you can go for the second alternative. First you think of the first method, then go for second method. Sometimes it also happens that once if you obtain first solution u equal to c1, and then to obtain another solution, that means b equal to c2, if this solution matches with some one of the three functions p, q and r, then we can put directly its value in this one wherever it matches. So the functional form will become constant form, and we can solve this very easily. And this we will also see by considering the examples. So everything now will be clear to you from the example. Let us see one example. Suppose we are given y cube minus xp, y cube minus xp equal to z. Now we want to solve this very simply. As I told you that once if you are clear to obtain the two different solutions u equal to c1 and b equal to c2, which method can be applied easier. But always think of the first method first, then go for second method. So if you will use this approach, then your solution process will become very, very simple. So now we go for solution. So first of all we will write down auxiliary equations. As I told you last time that whenever you start with the solution, then from the equation, from the given question, you start with given that means whatever is given. So you should write that given that y cube minus xp equal to z. Then you write down that auxiliary equation is given by, and one more thing here you remember. See, I told you earlier that equation can be written into the form of capital P into small p plus capital Q into small q equal to capital R. So first of all, whenever we want to write down dx upon capital P, that means capital P is the coefficient of small p and it is minus x. Then dy upon coefficient of small q, it is small y, and dz upon right hand side, and it is z. So these are the auxiliary equations. Now we want our target. Our target is to obtain two different solutions. So first of all we think about the first method, that is method of grouping. Method of grouping tells us that it is very easy. First of all, try to consider the first two equations containing dx and dy. And just observe, is there any z involved here? No. Then our problem is solved. Because whenever we consider the equations containing dx and dy only, then their functional form should contain x and y only. Then x and y we can bring together with dx and dy wherever we want, but z should not be there. Otherwise, if z is written, then z should be cancelled. So first method tells us that consider pair of two equations. So here we will consider taking first two equations, we get dx upon minus x equal to dy upon y. You can see. Now we solve this. Here there is no need of any other simplification because we can integrate directly. Here one thing here you remember that we are using the method of grouping or method of multiplier only for the purpose that our integration should become simple. The functional form should be in the way that we can integrate it easily. So here integration of dx upon minus x is log of x and it is log of y, and plus arbitrary constant. Normally we write down this as c1, c2, c3 like this. So here we will write down log of c1 because all the other structure is in the form of log. So now we give it simplification. We keep log of y over here on left hand side. So minus log of x minus log of y, minus if we take common, then in bracket we will have log of x plus log of y, but we know that log of x plus log of y is log of x into y, and this is equal to log of c1. Actually here we can also put minus sign if we want, because this is the constant, we can arbitrary constant, we can consider this into any common, and this minus sign only considered to avoid this minus sign on left hand side. So we will have xy equal to c1, and this is our first solution. Now we go for the second solution. For the second solution, we will consider another pair. We can take here, we will see the possibilities, dx upon minus x and dz upon z. Yes, we can take this pair. We can also take this pair, dy upon y, dz upon z. So here, if we take any pair dx and dz or dy and dz, then also the integration will be very easy for us. So whenever we consider a pair, then integration should also be possible. So suppose we will consider dy upon y equal to dz upon z. If you want, you can consider this pair also, but we are considering this pair. So here integrating, before you should taking, here you should write out taking second and third equations. We get this one. So then integrating. Actually, these lines, these sentences are required to to show the solution into more understandable form. So you can understand this very easily what you are going to do. Sometimes I will not write here because I am speaking in front of you. That is what is do and what is not to do. But whenever you attempt the questions in examination, then you will have to mention every line and everything, whatever you are going to perform, because there examiner will check your what you have used, your performance. They will check your performance, and they will not call you personally. And that means you will have to show this by means of writing. So log of y minus log of z and the log of c2. c1 is already used, so here I will write down c2. So therefore this will give us y upon z equal to c2. So this is the second solution obtained. So now therefore the general solution, or mostly we will write use this common sentence, required solution is capital F of first is xy, second is y upon z and equal to 0, and hence it is the solution, and you can get the 3 to 4 marks whatever is the weightage very easily. And one more thing here, you write out that if you want to write on y upon z here and xy there, you can do it. You can do it. Not necessary that you must obtain first this and second this, or second this, first this or second this. You can obtain the solutions based upon your idea, which you can use them easily to find out the solution. Now let us see another solution. See, we will see another solution. Pz minus Qz equal to z square plus x plus y whole square. Now see, now our speed will become faster, because no need to say further more. Here first of all, given equation is, first you write down the solution, given equation is this one. Therefore you can also write one more thing, capital P equal to minus z, capital Q equal to minus z, and the capital R equal to z square plus x plus y whole square. I will not write every time, but you must mention this in the solution so that your solution will become more clear. Then auxiliary equations are, I have written this auxiliary equation as a dot e dot dx upon z equal to dy upon minus z equal to dz upon z square plus x plus y square. Now I will identify the pair which can be taken easily and which can be integrated easily. Here it is easy to identify that we can take first two equations taking you write down that as in the first solution, taking first two equations, we can have dx upon z equal to dy upon minus z. I have considered these two this pair. However, z is involved here because I know, I have observed that z will be cancelled after taking this one. So z will not remain in existence here. So we will have dx equal to minus dy, and this is very simple. After integrating, write down that integrating this equation, we can get integration of this as x and this as y equal to c1. So this is the first solution. Okay. Now we will try for the second solution. For the second solution, we think of first and third equation. But here you see that when we take first and third, that means dx and dz, then y should not be there. So y should be eliminated by cancelling or any other way. But here we can see that x, it is written into the form x plus y whole square. So y cannot be eliminated easily. That means it cannot be removed. So first and third pair we can third equation we cannot take. Similarly, second and third equation also we cannot take, as we have considered first two equations. So second approach to obtain the second solution is, better we can use first solution is this one. If it is yes, then you can do it. If it is not, then go for another technique. This we will discuss in another example. That means we are going to explain all the techniques one by one. So go for, start from the easier method, then go for higher one. Here I can see that the first solution is x plus y equal to c1. So here I will replace x plus y equal to c1, then automatically x and y will be removed. There it will appear c1 only. So I can take this equation with second or with first one, any one. So I will take here first and last. So before of that you must mention this in words that taking first and third equations we have this one. So now we can see that we can write down this as dx minus z upon z we will take over here. So z square plus c1 square dz equal to 0. And it has the integration x, and z square is here and z is here. So derivative of z square is 2z is here. So it will come into the form of log. 2 is not there, so I have written 1/2. Log of z square plus c1 square equal to c2. And this implies, here I have not written log of c1 because not the whole structure into the form of log. So no need to write this log. So x minus 1/2 log of, now I will put the value of c1 after integration c2. So our final solution is capital F. The first solution is x plus y equal to c1. So x plus y. You don't write here x plus y equal to c1 form. Or simply write